If you're someone who is looking to know about AI, the basic fundamentals of artificial intelligence, what are the things that makes it work the way it does, then this video is for you. If you're an early professional, a student, a person who wants to know, this video is for you. Let's get started. Most people, when faced with the question, what is AI during an interview, will answer, yeah, AI is a system that replicates human behavior to help solve problems, whatnot. That really doesn't cut it. Everyone knows this. Everyone that gives the interview, apart from you, also knows it. That's not the answer that they're looking for. What they are looking for, on the other hand, is AI is a system that assists humans in making better decisions by ingesting data, accurate data, and utilizing compute resources, leveraging data centers through human talent. Okay, this together makes your answer of what AI is substantial and exhaustive, relatively exhaustive, let's say that. Okay, so the three elements that I told you here are: number one, compute; number two, data centers; and number three, human talent. It is very important that you understand all of these three, and this is what we are going to discuss in this video, and we're going to discuss this in detail. So now let's go to the first section, which is compute. In the compute resources that are leveraged by AI, there are three things that you need to be absolutely clear about. Number one is the CPU, number two, GPU, and number three, RAM. These are the core resources that AI leverages for it to do what it does. Okay, let us try to understand each and how each of them without the other doesn't work, but let's understand each of them separately. So the CPU, referred to as central processing unit, think of it like the brain of the entire thing, right? The CPU is responsible and it orchestrates everything that goes on, right? So the CPU does three very crucial things for AI to be successful. Number one, data ingestion; number two, data parsing and transformation; and number three, it's data augmentation. So let us understand each of these three briefly. Data ingestion refers to how, or basically the CPU inputting the data from wherever that data is, right? It may be in your storage, it may be in your hard drive, wherever. So it ingesting the data, it taking in the data for it to be processed. So that is data ingestion. Now, data can be in any form, right? You can give AI a picture, you can give AI a sound, you can give AI whatever, right? So in different formats the data exists. For that, it needs to transform it. That is where the parsing and transformation comes in. Okay, it converts whatever data is being inputted into a format that is recognizable by machine language. Okay, that is parsing and transformation, so that the machine understands the data. And finally, number three, and this is the key part, right, is augmentation. So here the CPU basically transforms your data into different forms of it for the AI model to get trained on. Okay, so for example, if you have given a certain sound input, like let's say my sound, right? So what the AI in the data augmentation part it does, right? So it has transformed the data into a language that the machine understands in the transformation step. Now what it does is it manipulates my voice, it changes my voice into multiple ways, in different speeds, etc., for the machine to understand as many possibilities of my voice as there exists. Okay, so that is data augmentation. So that's the three roles that the CPU does. Okay, now the CPU's performance is heavily dependent on the number of cores it has. So think of cores like building blocks, right? So the entire CPU is a building, and there you have building blocks. So think of it like this: a building, for you to construct it, for that matter, if you have only one worker, that worker will do only one task at a time, maybe 2-3 tasks at a time, but not so much, right? So the more number of workers you have, the faster the building is going to be built. So think of it like that, that the cores of a CPU represent these workers. So the more cores, better. Also, each core needs to be very good. Okay, so each employee, or rather each worker, needs to be good to make that building get constructed faster. Similarly, each core needs to be good so that each core can handle its own task, in computer language known as single threaded task, and then it also needs to be able to assist the other cores, one helper assisting the other, so that they can do the each of their work, and a work that is given together faster, which is known as multi-threaded work. Okay, so we understood what single threaded is: a core doing one task at a time, single threaded. Multi-threaded, many cores are required to perform that task, multi-threaded. So that is in a nutshell what the CPU does. Now once you've understood the CPU, now if you remember, the CPU kind of takes data. Now where is this data? That data is, yeah, in your storage, but storage data is normally stored in very slow, relatively slow places. Okay, that data is then pulled into something called as random access memory. Okay, this data is way faster than the storage level data, whether it's your HDD, hard disk, or SSD, solid state drive. Okay, your RAM is generally faster, and because of this, RAM kind of stores the data that is required for your analysis. Okay, so your RAM stores it because the CPU's storage ability is not that much, and we'll talk in the GPU section also. The storage capacity is not that much, although the GPU storage speeds are way higher, but again it can't store as much. Whereas RAM, it can store a lot, but again it's not as fast as GPU's storage, that is known as VRAM. We'll get into that when we go into the GPU section. But broadly speaking, RAM is basically where the data is stored for processing, for moving to the CPU, moving to the GPU. For that, RAM is there. Hopefully that is clear. Now let's move on to GPU. Now that you know about the CPU and you know about the RAM, the final element is the GPU. Okay, now the GPU and CPU share very similar traits, but are very different and meant for different purposes. Okay, the CPU is something which kind of is the brains, as I told you, right? The GPU, on the other hand, think of it like the muscles that execute things. Okay, these are the two things here. Now the GPU, similar to the CPU, has cores, but it is way faster. The GPU also has storage, which is less than that of the RAM from a capacity standpoint, but it is way faster, ultra fast. Okay, so the GPU is made of four fundamental blocks that you need to understand for the context of AI. Number one is the memory controller. Number two is the cache. Number three is the hardware scheduler, and number four are the cores. Now we'll start in reverse order. We'll talk about the cores first. Now the cores are similar to the thing that I mentioned about the hardware cores, right? But in the GPU there are hundreds and thousands of cores, whereas a CPU has some hundreds of cores. Okay, so the GPU can do very intense tasks. It can do at very fast. Okay, that's what the GPU is good for. Now these cores are relatively very small in size, way more with less storage, because of which you really can't store data directly in these cores for them to process, because of which there is something called as a cache. Now the cache memory sits very close, physically very close to the GPU cores, and the core can pull data very fast, right? That's what it does. Now because of this, okay, the data needs to move from the RAM to the CPU and eventually to the GPU, right? For this to happen, right, there is something called as a memory controller. Okay, the memory controller tells which cache to give the memory to the give the data to. Okay, so the memory controller acts like a traffic guard. There is another traffic guard. Okay, the other traffic guard is basically the hardware scheduler. Think of it like a reception person, that the data is there, and the hardware scheduler tells, okay, which room is empty, allot the guest to that room. Okay, think of it like that. So the data needs to be processed immediately by a code. Which code is empty, which code is capable, hey, send the data there. Done, complete. So, and the speed of the AI basically, right, it depends on all of these three elements. Just because you have a high powered GPU, that doesn't mean your model will be executed very well if your CPU and RAM are not good. All of these three things needs to be very powerful for the AI, for the coding to work. Understand, a code will not work without all of these three things. Okay? These are gigantic buildings, okay, where all of this compute storage that we talked about, very high performing compute storage, is stored, maintained, and then given to organizations who need it. Organizations like Microsoft, Oracle, Amazon, all of these organizations are providing data centers to organizations like, say, OpenAI, etc. So they're providing these things. Why? Because compute is very expensive and it requires a lot of physical space, so capital expenditure is very high. So not all organizations can do that. So that's why this is something which is very important. So organizations who cannot buy it use data centers, and that's why data centers are extremely important. And this is why most countries in the world are being told to create data centers, because they expect AI to be more prevalent in the future. And if they have data centers, it allows them to have a huge chunk of the revenue, etc. So that's why data center is important. Now let's move on to the final aspects. Now the final element of this is weirdly human talent. And why is human talent very important? Because humans play three very distinct roles, and three absolutely crucial roles. Number one, humans are the architect. Number two, humans represents what maintains and improves these algorithms and this technology and this software. Without humans, you cannot put guardrails and you cannot put safety over these algorithms and softwares. At the end of the day, humans are the decision makers on AI, right? So this is the end of the video. Hopefully you got an idea of what this entire AI ecosystem is. AI is not just coding and stuff. That is what I wanted to get through to you, so that when you are talking with someone, when you are going for an interview, that you have these ideas in mind. You can converse. If someone asks you, hey, why is there a GPU shortage, even if you don't know, you will think, okay, why is there a GPU shortage? GPU is very important for AI. That's why organizations that buying more GPU for AI and not leaving so much for people like me, people like you who may be gaming. So that's the thing. So hopefully this video was helpful. In the next video, I'm going to talk about AI in terms of how it impacts us, the good and the bad. And yeah, that's it. See you in the next video. And yeah, bye bye.